It's a pre-calc problem. It says write an expression for the volume. And what I have here, so I've got volume for part A, I've got volume is equal to 1/3 pi r squared h. And it says write an equation for volume as a function of h. So what does that mean? To write an equation for the volume as a function of h. Get rid of the radius. You want everything in terms of the height. You want volume expressed as a function of h. It's just like your equations, our basic equations for any kind of function. We pretty much always have a function in terms of what variable. Like when we're dealing with y equations, what is y always in terms of? X, okay? So here, we've got volumes in terms of radius and height. They want you to express the volume just as a function of the height. So very good practice here, some pre-calculus stuff. We know what h is. It says the depth h in feet of water, and that's the rate of change for h. So is that going to help us? Is the last line of this problem going to help us? No, rate of change is not going to help us right now because that's not what they're asking for. They do tell us that water is draining from a conical tank at a height of 12 feet. Okay, there we go. Height 12 feet, diameter 8 feet in the cylindrical tank with a base area of 400 pi square feet. Okay? So really what I'm looking for here is if I want to express the height or the radius in terms of the height, what do I need? What do I need to do? I need a proportion. I need the radius. I know the height is 12 feet. We know the radius would be 4 feet. But what I need to do is I need to be able to express the radius at any time, okay? And how it relates to the height. Well, you can look at that and tell, all right? But if you want to, you can set up a ratio. We can say at any height, we have a radius r. And we can say r is to h as 4 is to 12. And then we can solve. We have 12r is equal to 4h. And if we solve for the radius, we're going to get r is equal to what?
4h over 12, or 1/3 h.
1/3 h, which most of you can see that the radius is 3 times, or sorry, the radius is the height divided by 3, or the height is 3 times the radius. Most of you can look at it and know what the ratio is. But if you can't, then just set up the proportion and do it. You do get a point for this when you do this. In this part A. And the only reason is because it's no calculus in Boston. They got to give you some points somewhere. Then we do the substitution. So we're going to have volume is equal to 1/3 pi. Now, I might just go ahead and make that pi over 3. Pi over 3. Radius squared would be 1/3 h squared times h. Then we simplify. We're going to get volume is going to be equal to 1/3 h squared is going to be 1/9 h squared. Multiply the 1/9 times pi over 3. We're going to have pi over 27 h to the third. There's our formula for volume in terms of the height. Okay? Any questions? Good job. Part B. At what rate is the volume of the water in the conical tank changing when h is 3? Indicate the units of measure. Let me say that again. At what rate is the volume of the water in the conical tank changing when h is 3? So in other words, I want to know, so if I go back over here, this is going to be pretty key here. I want to know dV/dt, and I think they're way too nice on this problem. Okay, because they don't do this problem like this anymore. They wouldn't have done part A. Part A would have been included, part A and part B would have been more, and they wouldn't even have mentioned that you had to write volume in terms of the height. You would have had to figure that out on your own. You had to know, and let me tell you what I mean by that. So you want dV/dt when h is what? When h is 3 what? Do they have units here? 3 feet. And I have dH/dt. What's dH/dt? H minus 12. And that's feet per, probably feet per second, I'm assuming? Feet per minute. So that's what I have. What are some of the other things that change in a cone? What are some of the other things that change? The radius. So this is the step that some of you have been missing, is when you start out with your equation, the reason we needed to do part A is you can't do part B without getting rid of the radius, because the radius is what? It's changing. And since it's changing, you can't plug a constant in for it to get rid of it. Okay, because it's a changing variable. So we need to get rid of the radius, so that's what we did in part A. The radius now has been eliminated. The radius, it's not been eliminated, it's just been substituted for, and now it's expressed as a function of h instead of r. So it's still changing, it's still incorporated in there because we related h to r. But it's incorporated without having r physically in there, okay? So we're still compensating for the change in the radius, but it's been written in terms of the height, which we know. So volume is going to be pi over 27. That's why we're using this equation and not the original, because this says I have the radius. So now we want dv dt, we know dh dt, so we should be able to take a derivative. Don't ever plug in for a variable. Don't ever plug in for a variable that's changing before you take that derivative. Wait until you take that derivative before you plug in the variable. The other thing I like about this is it forces you guys to simplify the whole thing before you start taking a derivative. So we got dv dt is equal to 3 times pi over 27 would be pi over 9, h squared times dh dt. And then we're going to have dv dt is going to be equal to pi over 9, h squared times dh dt, which is h minus 12. Well, that's not a big deal because we know what h is. Yeah, we want to know dv dt when h is what? 3. So we substitute the 3, so we go pi over 9 times 3 squared times 3 minus 12. Should make sense that it's negative. Why? Should make sense that it's negative. It's decreasing, which, by the way, you did not need to make h minus 12 negative, even though we know the height is falling. They told you that the water in the conical tank was changing at a rate of h minus 12. We're assuming they've already accounted for that negative. And it looks like they did, because when you plug in the 3, what do you get there? Negative 4. So we've got negative 4 times 9. The 9's cancel, so we'll end up with negative 4 pi feet. What kind of feet? Whoa, we're going volume. Cubic feet per minute. And I don't know what that is as a decimal, so, and I really don't care. Wait, negative 9. I screwed up. Sorry. Sorry. 3 minus 12 is not negative 4. Don't take a picture yet, Camden. You gotta hold off. I screwed up. It's negative 9. My 4 was a 9. I just wrote it wrong. Okay? Any questions there? And then it goes on, it says, I think part C is it's interesting. You have to, it's problem solving. You have to think about what you have and what's happening here in this problem. Put yourself in context of the problem. Like, throw yourself here and say, if I was visibly watching what was happening, would I understand what they're asking in part C? And I think you could, if you think about it. Let Y be the depth in feet of the water in the cylindrical tank. Now we're not talking about the conical tank, we're talking about the cylindrical tank. So which one are we talking about? The cone, the Coke can, not the cone. Okay, so if we saw this big water tank, and you had this cone thing draining water into this big, catching water in this conical tank, all right, can you imagine what that would look like?
Yeah.
All right, and that's actually pretty realistic if you go to a manufacturing place. Like if you go to Baumgart's, there's actually something similar to this. It makes, and the only reason I know about it is because my brother-in-law actually went and worked. Kevin, you know my brother-in-law, Kevin, he actually goes and they have this thing that pumps in, it's stuff that goes in protein shakes. And that product, and it catches it in this big tank, and then they ship it off. And you ever had Wheeler protein shakes? Wheeler, the brand, GNC, any brand of GNC protein shake.
Oh yeah, that's
any brand of GNC protein shake, they get their main product for that protein shake from Baumgart's. Did you know that?
No.
And then they add all their other stuff to it to call it their special brand, their special sauce. But the main product comes from Baumgart's and places like that. There's like 4 different places in the country that provide that. Baumgart's one of them.
It's awesome.
Yeah, it's pretty cool. So let Y be the depth of the water in the cylindrical tank, and at what rate is Y changing? So that's the depth. So we're talking about what here? What are we talking about? We're talking about the height changing. y is the depth. So we're talking about the rate of change for dy dt. At what rate of change is dy dt, so this is part C, dy dt, changing when h is 3? Okay? Indicate the units of measure. Now, if I'm going to do this, what do they give me? Do they give me anything in the problem about the cylinder that might be helpful? They give me the base area. They say the area of the base of the cylindrical tank is 400 pi square feet. That's kind of important, right? Would you say that? Do you agree? So the area of the cylindrical, I'm going to say area of the cylinder, CYL, this is good enough, is 400 pi square feet. Now let's talk about the cylinder for just a second, because the cylinder is much different than a cone. What changes in a cylinder? Tell me the things that change. Height and volume. Will the area change of the base? Why? Because the radius never changes. The radius is constant, which is fabuloso. You know why? Because that means if I'm going to talk about the volume for the cylinder, the radius is constant, which means I can plug in for the radius. Well, I don't have the radius. I have the area. Well, that's fine, because the area is also constant. What happens to be the volume of a cylinder? What's the volume of a cylinder? It's the base area, which we happen to have, pi r squared, times the what? Height. We already have that. That's the 400 pi. We already know that. And so we've got V is equal to 400 pi times H. And now, so I look at my formula, I'm thinking, okay, I got a formula that relates the height to the volume. They want to know the change in the height. Do we know the change in the volume when H is 3? Yeah. You do. Let me tell you why. Throw yourself physically there in the problem. What did we do in part B? We found out the rate of change of the volume when it was draining from the conical tank when H was 3. The rate of change for the volume of the tank when H was 3 was negative 9 pi cubic feet per minute. If that's draining out of that tank, where is it going?
It's filling into the big
It's
one.
filling the cylinder. So this is negative 9 pi cubic feet per minute for the cone, but what is it for the cylinder? Positive 9 pi cubic feet per minute. Pretty simple. So now that I have my volume formula, I can say, okay, dV dt is equal to 400 pi times what? dH dt. I don't want it. That's what I'm looking for. I'm looking for dH dt, which is the same thing as dy dt. We called it y. Okay, who cares? Y, h, whatever. You want to change those h's to y's to represent the depth, fine. And I know dV dt. What was dV dt? Not negative 9. Negative 9 is draining out the cone, but it's going into the cylinder, so it's positive 9. So we're going to come over here and we're going to have 9 pi cubic feet per minute. 400 pi. And 400 pi, that's in what? What's the units for 400 pi? Feet squared. Times dH dt. Divide by the 400 pi. What's going to happen to the pi's? Cancel. What's going to happen to the feet? Cube divided by feet squared. You're going to end up with feet per minute. So you're going to get 9 over 400 feet per minute for dH dt. There's your answer. Very interesting problem. Okay, any questions there? Good to go? All right, let's go to the next one. Let me clear that one. All righty, 1995, AB2. All right, so we got some particle motion stuff now. I'm not going to do as much on this problem because of what it all entails, but I can talk about what is happening for the parts you don't know how to do. Particle moves along the y-axis. So now we're talking about a particle, let's say, moving up and down a rope. Yeah, remember those, you know how we know, we don't have a rope that you climb, but you ever seen the movies in gym class where the students are always climbing the rope? So let's just imagine, you know, Max is climbing up and down the rope. You know, he's like, you'd probably be pretty good at that anyways. And so, you know, you're kind of sliding up and down this rope. Oops, never mind. Can't move the whole thing. Anyways, you get it. So you got this person, or you can talk about the squirrel in the tree. You know, getting the acorns, bringing them up and down the tree. All right. So a particle moves along the y-axis so that its velocity at any time t greater than or equal to 0 is given by the equation v of t is equal to t times cosine t. At time t equals 0, the position of the particle is 3. So in other words, they're telling us the position of the particle at 0. So they're saying, usually I say position is s of t. If they specifically tell you the position is a particle moving along the x-axis, they'll use x of t instead. Still means position. If they say the particle moves along the y-axis, they'll say y of t. They all mean position. And the derivative of all of those is still velocity. Okay? Instead of using generic s, they use x and y specifically when they say it moves along the x-axis or y-axis. Okay? So we're talking about it, just this point, moving up and down the y-axis. And there's a function that models that position. I don't know what it is because they just gave me velocity, but there is a function that models that position. And it looks like it's a trig function, probably because that thing's bouncing back and forth. So it's kind of like harmonic motion in physics. It's kind of like a spring. It's ball, bouncing ball kind of thing. All right, so we're looking at y of t. And this means right here, if t equals 0, then y equals 3. That means y of 0 equals 3. That's what that means. Y of 0 equals 3. All right, let's go through it. It says, for what values of t from 0 to 5 is the particle moving upward? So what am I going to do to figure out what values of t is the particle moving upwards? Sign analysis. Now, this is a calculator problem. And I did have a graphing calculator this year. It was a TID1, but I did use the graphing calculator. I wasn't very good at it. Okay, so you're going to take your v of t equation, v of t, and I'm going to set it equal to what? To do a sign analysis, I'm going to set it equal to 0. Now, we are completely and totally going to look at this by hand and with the calculator. So have your calculator out. Let me show you how you would do this both ways. Okay? First of all, by hand. And then I'll show you how much easier it is with a calculator. By hand, you got t cosine t equals 0. And first step would be to find the critical values, correct? And it says from 0 to 5 only. So I'm only going to do my sign analysis from 0 to 5. You follow me so far. So if I do this, I've got two values. I've got t equals 0. Got that right? Oh, that's already included. We're going from 0 to 5. And then cosine t equals 0. Where does cosine equal 0 in radians? Pi over 2. Is that between 0 and 5? That's 1.57. So pi over 2. What else? 3 pi over 2. Is that between 0 to 5? Yeah, that's 4.71. If I go a little further, is that going to be too far? Yeah, so because it goes from 0 to 2 pi. 2 pi is 6.28, so the next value would be outside the 0 to 5 range. So we're going to do our sign analysis from 0 to pi over 2, from pi over 2 to 3 pi over 2, and from 3 pi over 2 to what? To 5. And it might be handy to know that this is 1.57 and this is 4.71, just so when you're doing your test values, you know what to think of here. All right? So let's test 1. Actually, no, let's don't test 1. Let's test something on the unit circle that I can do in my head. Give me something between 0 and pi. That would be easy to test on the unit circle.
Pi over 4.
Pi over 4, I like that. Pi over 4, is it positive or negative?
Positive.
Positive. Pi over 4 is positive. You got a positive times positive. What is it? All right, let me go ahead and tell you right now that the shortcut is the signs always alternate unless you run into a double root, and I'm going to tell you when we run into a double root, and we haven't done it yet, so you're going to go ahead and see they alternate, but we'll check it just to make sure. Pi over 2 to 3 pi over 2. Give me a value. Pi works, okay. Pi there, cosine of pi is what? -1, so what's a positive times a negative? There you go. This should be what, the next one? Positive. Let's see if we're right. Try 7 pi over 4. 7 pi over 4 makes this positive, positive times a positive is a positive. The question is, when is it moving upward? So what would you say? Now on the AP exam, you would actually say when velocity is positive is when the original position function is moving upward. That's because if you look back to the original position function, the slopes would be positive, and if you have positive slopes, the y value is going up. It's kind of a duh, yeah, that makes sense. That's when it would be going up. Because the graph, whatever the original graph is, it probably looks something like this. So velocity is telling you when those slopes are positive, so when the slopes are positive, oh yeah, that's telling you the positions, oh yeah, the positions are on their way up every time when the slopes are positive. All right? Does that make sense? Now, that's how you can do it with your calculator. By the way, here's how you would write it on the AP exam. They don't, I'm going to have to say this in class, I haven't said it yet. They never look at your sign analysis. They're actually trying to cross out your sign analysis. Why do you need it? Because that's where you get your information to answer the question. So the only way they would give you points for this is after you do your sign analysis, you have to write it out. You have to say the particle is moving upward from 0 to pi over 2 and from 3 pi over 2 to 5. They are trained not to look at any student's sign analysis. That's for you, not for them. And then what you have to do is take the sign analysis, interpret it, and then answer the question. Okay? They don't even get points for sign analysis. All right? So, here's how you can use your calculator to do it. Because sign analysis is not even required, and this was a calculator problem, so watch how you can answer this with showing no work. What would you do? Plug velocity into y equals. Do this. This is so useful. You're going to do this all over the calculator portion of the exam. You're not going to have to show sign analysis. Plug in velocity. That's the only equation we got. Make sure your calculator's in radians. And I'd press zoom 6. Actually, I'd set my window from 0 to what? I only need to look from 0 to 5. Agree? Let's just set the window from 0 to 5. So hit zoom 6 and then change your y min and change your x min and x max to 0 to 5. So x min would be 0 and x max would be 5. And if you reset your window, your y min should be at -10 and your y max should be at +10. Agreed? All right, let's graph. There's your velocity curve. Now, we were doing that in the orange book last night. This is velocity. You are looking at velocity. Should look something similar to Marley's. Now, it's a little squished here, a little squishy. So if you want to unsquish it a little bit, what could I do? You could change the y min and y max to like -5 to 5, and it won't be so squishy. Okay? So it goes from 0 to 5. This is velocity. What do you look at here when you're trying to interpret the signs? Where it crosses the x-axis and where it's above and below. Where it's above the x-axis is where velocity is positive, which means the original particle is moving what? Up. Where the velocity is negative is where the original particle is moving down. So velocity is negative where it's below the x-axis. And if you do a second trace, I'm guaranteeing that you're getting 1.57 for one of those and 4.71 for the other one. Try it real quick. What would you do to figure out those values? Second trace, number 2, 0. And that's where you do a left bound, right bound guess. Just try it. Make sure you can get the 1.57 and the 4.71. If you can't, I'm going to look like an idiot. All right. Colin got 1.57. Did anybody do the other one to get the 4.71 by any chance? Oh, it's way over there. Did everybody get 1.57 at least? Yeah, Rosie's row, everybody got one. Or Sam's row, everybody got 1.1. The other one's 4.71. So you see how you would do that? Then you get the x-intercepts like Mason saying, and now you can say, all right, once I know where it crosses the x-axis, I can say, okay, it's above here, and it's below here, it's above here. You'd say it's above from 0 to 1.57, it's below from 1.57 to 4.71, it's above from 4.71 to 5. Now you can answer the question. Where it's above is where the original particle is moving up. Do you see how you use the calculator to answer that? Is it quicker? Did we show any work? If you're allowed to use a calculator, should you even show the sign analysis by hand? You shouldn't do the algebra by hand, but you could write out the sign analysis if you wanted to make sure you kind of documented something. So you said, okay, let me write it out to make sure I'm understanding what it is I'm looking at. And I really encourage, even if you're using the calculator, still write out the sign analysis. It's just, you just don't have to do any work to get the sign analysis. You just got to look at it, just write it out, there it is. And then say, okay, now I can interpret my answer.
So you still would have to find the t equals 0, t equals pi, and t equals 3 times.
You still got to figure out where it crosses. I mean, that's how you're going to say where it's moving up or down. You reference where it crosses.
I'm not sure I said how much work we get this.
What year is this? 1995?
AB2.
AB2, I can tell you exactly what they gave points for right now. Looks like to me, the only points they gave is for considering, is just saying, I'm looking, you would need to say something along the lines, the particle's moving up from 0 to pi over 2 and from 3 pi over 2 to 5 because V of t is what? Positive, 2 points. They might give a point for each interval, but you have to say, if you don't, since we're interpreting from the sign analysis, you have to say it's moving up from these values because either the velocity graph is above the x-axis or you say velocity is positive. You have to say something about the reason is because the velocity is what? Positive. You got to state why. You can't just put answers. You got to tell them why. It is what it is. Okay, part B is the only other thing I want to do here on this one. And that's just a straight derivative part. So we have V of t. What are they asking you for in part B? They're asking for A of t. Okay? Write an expression for the acceleration of the particle in terms of t, so just take the derivative. What rule are you going to need to take derivative? They don't do them this easy anymore, just so you know. You're going to think my exam was a joke compared to y'all's. Cosine t. Probably like that doesn't sound very good. All right, t times negative sine t. So you're going to end up with cosine t minus t sine t. There's your acceleration at any time. And the reason we're not going to do C and D is because it is now a VC topic. You're not responsible for it. It's integration by parts. So I did have to know something more than you guys. But I didn't do well anyways. All right, what was the next one we did? 83. Oh, it's right there. All right, this problem, muy awesome. Okay? All right. Let me pause for station identification.